Hello, my name is Lydia Rayborg. I'm in Neuroanatomy 1, and today I'm going to be talking about the gray matter of the spinal cord. So, as a general overview, this image here shows a cross-section of a spinal cord. We can see the blue represented as the gray matter, and the columns around represented as the white matter, where all of the axons are. We can see that the arrows going in are sensory afferent neurons coming in through the dorsal root ganglia to the dorsal root of the horns, being relayed and then sent out through motor efferent neurons in the ventral horns. So I'm going to be talking about the 10 layers of Rext laminae, which are based on structure and function. In this image here, we can see the nuclei, which are grouped on location. So I'm going to be doing a little bit of comparison between the two and explain the structure and function of each laminae. So laminae 1 through 6 makes up the entirety of the dorsal horn and the nuclei. That will be the marginal zone, substantia gelatinosa, nucleus proprius here in green, yellow, and orange. And so you can see 1 through 6 all in purple and pink right there. So lamina 1 is the very tip, receiving noxious pain, damage, or stimuli. That can be mechanical, chemical, or thermal. Lamina 2 is going to receive all sensory-related stimuli, modulating sensation of pain and corresponding with the substantia gelatinosa, and that is going to communicate directly with lamina 3 and 4. Lamina 3 is going to be sensations of proprioception and light touch connecting to lamina 4, 5, and 6. Lamina 4 is going to be reception of non-noxious sensory information and processing. Non-noxious just meaning non-painful. That is going to connect to lamina 2 and the nucleus proprius. Lamina 5 is going to relay sensory information, which would be nociceptive or pain signals to the brain via the lateral spinothalamic tract, and receiving descending information from the brain via corticospinal and rubrospinal tracts. And all of those tracts are going to be in the white matter. The lamina 6 is only present in the cervical and lumbosacral enlargement from C4 to T1 and L2 to S3. And that is going to be made up of small interneurons involved in modulation of spinal reflexes, receiving sensory information from spindles, and it will be involved in proprioception. And then it's going to send information to the brain via ipsilateral spinocerebellar pathway. So that concludes the dorsal horn of the gray matter in lamina 1 through 6. Let's move on to lamina 7. We can see that it forms the middle region between the dorsal and ventral roots, and it is a large heterogeneous zone varying the length of the spinal cord. It will be different in different locations. And it's going to receive information from lamina 2 through 6 and from the viscera. It will relay motor information back to the viscera and give rise to cells involved in the autonomic nervous system. So that would be functional or regulational cells. And it's going to partially correspond to the dorsal nucleus of Clark. Right here you can see in brown versus in purple there. And lamina 8 is 8, 9, and 10 are going to be motor voluntary lamina, which would correspond with the ventral horn of the spinal cord. So lamina 8 is the most prominent in cervical and lumbar levels, modulation of motor output and skeletal muscles, and it's going to partially correspond to the lateral and medial motor neurons. Here you can see in red and brown versus red over, green. So lamina 9 is going to be three clusters actually, of large alpha motor neurons innervating striated muscles. And that is going to vary between the levels in the size and shape of those clusters. And it's going to partially correspond to the lateral and medial motor neurons. So you can see in red there, those are the three clusters, and you can see it on this page as well. And finally, lamina 10 is going to be around the central canal of the spinal cord, known as the gray commissure, and this is where axons are going to cross over from one side to another. So thank you so much for listening.